In the realm of fairness-aware learning, research has predominantly centered on individual modalities such as tabular data, text, and images. However, there is a significant gap in the exploration of multimodal systems that integrate information from various modalities. This study delves into the fairness and bias implications of multimodal fusion techniques within the context of AI-based recruitment systems, utilizing the FairCVdb dataset. This dataset provides diverse data including images, text, and structured data with intentionally designed gender and ethnicity biases. The authors investigate early fusion and late fusion techniques, known for their straightforward interpretability and widespread usage in multimodal AI systems. Early fusion integrates each modality's unique characteristics, while late fusion combines the outputs of individual modalities. The results reveal that early fusion closely matches the ground truth for both demographics, achieving the lowest mean absolute errors, MAEs, by integrating each modality's unique characteristics. In contrast, late fusion leads to highly generalized mean scores and higher MAEs. These findings underscore the significant potential of early fusion for accurate and fair applications, even in the presence of demographic biases compared to late fusion. Future research could explore alternative fusion strategies and incorporate modality-related fairness constraints to enhance fairness. In multimodal learning, early fusion and late fusion strategies are employed to combine features from different modalities. Early fusion concatenates features early on, simplifying training and capturing interactions between modalities, whereas late fusion processes each modality individually before combining outputs, offering flexibility and allowing different processing pathways for individual modalities. This investigation explores how these fusion strategies impact bias and fairness in automated recruitment processes, utilizing the FairCVdb dataset, which comprises 24,000 synthetic resume profiles with demographic characteristics, textual, visual, and tabular data. Each profile has a numerical score, either bias neutral or biased, simulating scenarios where cognitive biases influence decision-making. The evaluation metrics used are mean absolute error, MAE, to measure prediction error and Kullback-Leibler divergence, KL, to assess demographic bias. The models are extended to facilitate multimodal recruitment learning using early fusion and late fusion techniques for all three modalities. Two simulated setups are investigated, an unbiased ideal world setup and real-world setups with gender and ethnicity biased scores. The evaluation results show the KL divergence, MAE, and score distributions for gender and ethnicity across different modalities and bias setups. In the unbiased ideal world setup, the ground truth distributions are closely aligned for both demographics, with the tabular modality exhibiting a lower score distribution centered around a mean of approximately 0.5. The results highlight the impact of fusion strategies on bias and fairness in automated recruitment processes, demonstrating the potential for early fusion and late fusion techniques to mitigate or exacerbate bias in different scenarios. Analyzing the distribution of hiring scores by gender and ethnicity reveals significant disparities across different modalities and bias setups. When examining the scores through various metrics, including Kullback-Leibler divergence and mean absolute error, the results show a mix of neutral and biased distributions. Notably, the textual modality exhibits a bimodal distribution, indicating its ability to effectively distinguish between instances with high and low scores. The gender-based analysis reveals distinct patterns, with certain modalities displaying neutral bias and others showing biased distributions. For instance, the KL divergence scores for female and male candidates differ substantially, suggesting that the hiring system's performance varies significantly across genders. Similarly, the ethnicity-based analysis uncovers biased distributions in certain modalities, highlighting the need for careful consideration of ethnic diversity in hiring systems. The mean absolute error scores further corroborate these findings, emphasizing the importance of understanding the performance of hiring systems in terms of bias and accuracy. These insights are crucial for developing fair and unbiased hiring practices, as they underscore the potential for certain modalities to perpetuate existing inequalities. By recognizing and addressing these disparities, researchers and practitioners can work towards creating more equitable hiring systems that minimize bias and maximize accuracy. The study examines the bias implications of early and late diffusion strategies in multimodal AI-based recruitment using the FairCVdb dataset. It assesses biases in gender and ethnicity demographics across both unbiased and real-world setups. The findings indicate that early fusion closely mimics the ground truth for both demographics, achieving the lowest mean absolute errors by effectively incorporating the unique characteristics of each modality. In contrast, late diffusion tends to overgeneralize the mean score, resulting in higher mean absolute errors and Kullback-Leibler scores. The study highlights that leveraging multimodal data can enhance performance and mitigate bias compared to relying on a single modality. However, blindly fusing all modalities may not always yield the best results. Future research should explore mid-fusion strategies to enhance fairness and accuracy in decision-making through strategic selection and combination of modalities. In multimodal machine learning, early fusion strategies play a crucial role in achieving both accuracy and fairness, particularly in high-stakes applications like automated hiring. Unlike late diffusion approaches, which result in overgeneralized mean scores and higher mean absolute errors, early fusion methods provide robust solutions even in the presence of demographic biases. The evaluation highlights the potential of early fusion in mitigating these biases, underscoring its significance in real-world applications. Mid-fusion strategies, which strategically select and combine modalities, may offer a promising avenue for enhancing fairness and accuracy. However, further exploration is necessary to validate these findings across diverse datasets and domains beyond hiring. This is essential to broaden the study's impact and relevance, ensuring that the benefits of multimodal machine learning are realized in various contexts. The use of simulated or synthetic data in automated hiring processes raises critical concerns regarding fairness, transparency, and effectiveness. It is essential to understand the risks associated with these approaches and develop strategies to mitigate them. This research was supported by the European Union under the Horizon Europe Mammoth Project and the EU Horizon Europe Project Stellar, as well as the UK Research and Innovation Grant. Multimodal learning has been extensively explored in various studies, with a particular focus on the comparison between early and late fusion methods. Research by Barnum et al. 11, Pereira et al. 10, 12, and Bayud et al. 13, collectively highlights the importance of understanding the benefits and limitations of different fusion strategies in multimodal representation learning. Early fusion, as demonstrated by Barnum et al. 11, significantly enhances the performance of multimodal systems. In contrast, Pereira et al. 10, 12, conducted a comparative analysis of early and late fusion methods in the context of the multimodal two-class problem, providing valuable insights into the trade-offs between these approaches. These findings underscore the need for a nuanced understanding of fusion strategies in multimodal learning, as different methods may be more or less effective depending on the specific application and problem domain. This comprehensive overview provides a foundation for further research into the development of optimal multimodal representation learning frameworks.